Right. Yes, we're going to talk about the latest changes to DataSHIELD, and in particular the DS base, and the ones which is essentially we're looking at the changes which have been made and will be made as well. Changes will be made before this conference and ones which will be made shortly. When looking at this, but next slide, Alex. Thank you. So it is getting slightly more complicated to say what is DataSHIELD now, because there's such a plethora of new packages and functionality to be added since the last conference. So what we're going to do is just really concentrate on the DS base, which contains the essential statistical functions which practically everybody who uses the system will need. But I'd like to point out, though, there are lots of new packages are now available which address particular domain-specific needs for users. So next slide. I think it's over to you, Alex.
Yeah, over to me. So yeah, Stuart and I put together this presentation. Wrote this as the most simple summary we could for DSBase. So DSBase provides the common base statistical methods in DataSHIELD. And so because of the importance of that, we're going to just be covering what's been happening recently. So those are versions 6.1 and 6.11, which have happened late last year and this year respectively. And then I'll hand over to Stuart so he can tell you how things will change very soon when version 6.2 releases. So we've color-coded it. 6.1 will be the orange in the top left, the icon, and then when I hand over to Stuart, it'll be a green icon, top left. And we've tried to arrange our thoughts, firstly, just selecting the most interesting and relevant changes to functionality, and try to arrange it in terms of motivation for the change and then how we've implemented that. So this is the summary of what I will be talking about. So version 6.1 is the left column. So quite a few new functions and presentation functions. I'll just quickly highlight ds abs and ds square root. So the absolute of a numerical vector and likewise the square root of one. But because they're quite simple and they simulate what happens with base are absolute and square root commands. I'm just covering them now, but we won't go in depth into them. As well as new functions with each patch, there is often change functions and change the behavior of how things work. So I'm going to talk to you about cbind and scatterplot for that. And then I'll just do a quick final slide on some additional changes that were made in 6.1, which released earlier this year, I think April. So this is the two key functions that have changed in version 6.1. So GLM predict and GLM summary, as you can tell from the name, they are to do with our suite of generalized linear modeling functions. So the predict one, predict GLM as it is in base R, will take a model and then create predicted values based off the attributes of that model. And especially for this particular function, it can be set up as an aggregate or an assign type method. So you can set it off, plug in the various arguments that you need, and it will create an object server-side, just like native R will do, but stored server-side. So then it's left on the server, and you can either leave it there to subsequently manipulate it. One thing that Dimitri and I did was to add it into a scatter plot to see how well the scatter plot was fitted by GLM predict. But alternatively, you can return the summary values. So that has been edited to only return especially non-disclosive values. So Sorry, yeah. So then moving on to GLM summary. In base R, the summary will be a small table printout of the key GLM object attributes. And because this is bringing back information to the client side, so we're calling that the aggregate type method. And it only returns some elements of the base R GLM summary. So the ones that were deemed to be disclosive were left out of our customized DataSHIELD function. So moving on to kurtosis and skewness, these are two new functions added for 6.1. And I'm sure if you have ever used kurtosis or skewness in your regular R sessions, you'll know exactly what they do. So now they're available to use in DataSHIELD. The three different methods of calculating the kurtosis and skewness, respectively, are included as they are very similar, or as close as possible as the native R function, which is included in package E1071. And these are just two example printouts I made of the kurtosis. So you've got kurtosis by study, but one of the arguments you can read in the help function is how to do combined instead of separated. Moving on to box plot. So a method for portraying the central tendency. It can also be split by group, as it has been here. So that's split into groups by gender. I believe that could possibly be a factor. This one has been provided by Xavier. Yeah, so this is one of the first instances of a DataSHIELD function being developed by an external member of the team. So thank you very much to Xavier. And also it's the first DataSHIELD graphical function that implements ggplot into the function. So you don't have to take the values and go elsewhere to get them into ggplot. It's an aggregate type method because it's being brought back here to the client side. And these tails, while they might look disclosive, aren't actually the same as the regular box plot. They're just a ratio of the interquartile range, the default being 1.5 times that. Moving swiftly on, some other highlights of 6.1.0. We've changed scatter plot so that the returning of coordinates is available. So instead of just having a DataSHIELD graphic created, you can instead return these anonymized data points and then plug them as a vector, I believe, or a data frame into ggplot and create much more interesting plots based on your knowledge of ggplot. cbind, so we've modified this function so that it correctly binds columns when the order of columns is not the same across studies, which is an error we picked up through user reports. Other things occurring in 6.1.0 are documentation improvements, improved testing, and some additional argument checking. Now I'll just be really speedy so I don't leave Stuart with too little time. Additional things in 6.1.1, so that's the most recent smaller patch. We've improved the DataSHIELD error messaging. So we've got new stop functions included in many functions so that it will actually tell you something about why it suddenly stopped working. Hopefully good for the user experience. For DS complete cases, we've ensured the correct behavior if that is applied to a vector because it only used to work for data frames. In modeling, these two generalized linear modeling functions now have the capability to assign them to server-side for subsequent manipulation, as I mentioned in the GLM slides. And then some changes to recode values, and of course, as expected, bug fixes, documentation improvements, and additional testing. So now I'll hand over to Stuart to talk about 6.2. Oh, there you go.
Thank you, Alex. So what I'm going to talk about is the up and coming release of 6.2. So this is a release which will have quite a lot of well, a number of new functions and quite a lot of changes to generalized improvements. So not only does that, but one of the major additions is also some more options in the way of disclosure control and some general improvements to the usability of DataSHIELD, in particular error messages and the addition of quite a lot of argument checking. Alex, next, please. So the first of the new methods is dsDMTC2S. Now, the purpose of this is to permit the transfer of complex objects from the client to the server. The DTM, as you probably guess, is you can transfer data frames, matrices, and tables from the client to the server. So this will allow people to add their data, which they have at the client, into the servers, and so that can take part in any analysis operations. At the bottom, you can see some examples of its use. As you can see, it's fairly simple to use. All you need to do is specify the object in the client environment which you want to transfer, and the name of the object you want to transfer it to in the server. Alex? Right. There has been, we've heard information back about as factor, in that people are running into problems because there were circumstances where it was causing indicating a disclosure problem, although the way that people wanted to use it, it wouldn't really be a problem, or it's not appropriate for a disclosure problem. So what Dimitri has done is add a new function, ds as factor simple, and what that does is it's like a simplified form of the original as ds as factor, and what it doesn't attempt to do is enforce the consistency across the data sources. The advantage of that, in not doing that, means that you can get back the factors, or you can assign them to the server without disclosure checks being issues being flagged to you, blocking your work. So you can see at the bottom there, there's yet again a little example, simple again. You just indicate which object on the server you wish to apply this operation to, and where you would like the results to be placed. Right, Alex. So this is another plotting function which has been added for this release. It allows you to do forest plots of the coefficients from a study level meta-analysis. This is again being provided by Xavier. And one interesting thing to note is this is a client-only addition. It uses existing operations of the server to accomplish this. So what you would do is you would create yourself a GLM SLMA object model, and then you can invoke this operation on it to cause it to be plot. There are a number of additional arguments you can pass out, variables, the method, and the layout, so you can customize the graphics you have. Right, Alex, next one, please. So I've dealt with the kind of new functions. Now it's going to go into some of the improvements we've done to existing operations. The correlation testing operation, dsCore test, that used to only support the Pearson approach to doing correlation coefficients. Now it also supports the Kendall and the Spearman. This has been kind of, Dimitri has spent a lot of time understanding what people want for this function, and yeah, he's added other features like you're able now to set the confidence level for the confidence interval. I believe that's only for the Pearson algorithm though. And also the fact that this supports now not only getting the split type results, which is one from each, the results from each of the studies, but you'll also combine them if you wish it to. Next one, Alex, please. Right. As I mentioned, there were some issues with the fact that DS as factor was indicating quite often the disclosure problem. And what we've done is actually refined that slightly to make it more configurable to what you'd want to see in a way of disclosure issue. Used to be there was this single function, a single option you had, n filter levels, which you could specify how disclosure would be observed. Now we split that into two, so you not only can specify the maximum, but also the density of the results. I think all these will be explained in more detail in the release notes. So, I'll move on now to an additional functionality, which it's not going to affect. It doesn't give you extra analysis operations, but it will allow the data owners to put the server into either a permissive or non-permissive mode. This ties in with the fact that profiles will be becoming available soon, and so what will allow data owners to do to decide whether a particular user base can have it in permissive mode or non-permissive mode. The effect of putting the server into a non-permissive mode is to block certain operations from being performed. These, which are listed below. Well, thank you, Alex. The result is that those users won't be able to use those operations. What could be done is that the data owner could then perform some of these data reshaping operations on behalf of the user before they actually use it. Next one, Alex. Right. I think we're all rather aware that at times DataSHIELD can provide some rather uninformative error messages. So we've made an effort to try and trap or improve those methods or those error messages. One of the key things is that we've added checking to make sure that if you're trying to use a name of an object on the server, that object does exist before it tries to perform operations on it. It used to give some very uninformative messages if you try to do that. So not only check that it exists, but it also check the actual type of the argument as well. This ties into another issue which people have observed, is the auto name completion within native R, which means that if within your request you ask to operate on, for example, an object called foo, even if it doesn't exist, but there is an object called foobar, it will perform the operation on foobar. This has caused problems with certain studies who have structured their namespace within their data into hierarchical structures. So we've put in quite a bit of effort to make sure that this doesn't happen anymore. So it'll only operate if the actual object does exist. Next. So to emphasize that if you want to monitor and understand the release, there are parts of the forum dedicated to releases and other into general news. So that's where we will be posting updates about the schedule and also things like any different any new functionalities we had. So I noticed, just if there's any questions, I just noticed one question was, what is the release date? Well, we want to release it soon, so it could be done shortly, but also we want to test it against the latest versions of the support software. That'll be Opal and Armadillo, and we'll try and do the version of Armadillo which has got the profiles built into it. So Alex, could you have a check of what the actual other questions?
Yeah.
Sorry, I was stuck on muted. Yes, so thank you both for your presentation. There was further discussion in the chat around the forest plot function as to whether it's something that's possible in current versions, or so is this a sort of wrapper for functionality that did exist previously?
My understanding, I think Dimitri can correct this, is that you were able to get the information for a forest plot before, but this one has sort of integrated it into the client side.
Okay.
So you could have done the same operation by hand, but now it's actually supported.
Okay. Great. Was there any further questions for Alex and Stuart? Please raise your hand if so. One question I had actually was relating to the DS box plots function, and you mentioned around the use of the 1.5 times interquartile range on the tails to avoid disclosiveness. One concern that sometimes comes up in terms of disclosure control is around the number of observations in each, say, percentile. So if you're presenting the mean or the quartiles here, are you assessing whether actually that refers to a single observation in the data, or is there a threshold that it has to conform to a minimum number?
I think that could be a question of Xavier, but I'm not quite sure if he's here.
Well, Paul's raised his hand if you wanted to.
Sorry, can you hear me? Great. Can I just say that that's specifically one of the issues. So there's a new function. Literally, I'm virtually finished writing it now. It's got a whole lot of functions as part of it. It's got 2 client-side functions and about 7 server-side functions. It's for non-parametric analysis, the construction of quantiles, and that specific issue you've just raised is one of the traps that I build into that.
Right.
So basically, the total number of observations driving the production or whatever you're producing is too small relative to the number of things that you're trying to put as the output. It will block you using one of the disclosure traps. And so it would be fairly easy if anybody wanted to, if it's not available as part of this, to implement the same trap on this.
Yeah. So we just had an update from Javier in the chat to say that it's taken into account as far as he remembers, but he will double check before the release. So yes, that sounds promising, and well done. Thank you, Javier, and thank you, Paul. Did anyone? We've probably got time for one further question, if anyone has any. Any hands go up? No? Well, I think we're all looking forward to seeing the new version and when it's ready, and playing around with some of these new tools. So I think we'll move on to our next talk in this session. And this talk is from Yannick Marcon, who I'm sure most people are familiar with here, is involved with Epigeny and has an extensive history of supporting the development of DataSHIELD. And his talk is on the DataSHIELD infrastructure updates and upcoming developments. So I will hand over to you, Yannick, and look forward to your talk.
Okay. So this talk is about giving you an update on the DataSHIELD infrastructure. And then I will go back to 2 years later because there has not been. Oh, can you see my screen?
Yes, we can. Thank you.
I had a message, but you couldn't. Okay. So I will go back 2 years later because there was no DataSHIELD conference since then, and a lot of things happened. So the different topics will be the resources, the profiles, and the deployment, and the future of the development of DataSHIELD infrastructure. So yeah, as you said, probably most of you know me, and so I'm maintaining the DataSHIELD infrastructure and several R packages and CoPI at Maelstrom and Consultant. So about the resources, the DataSHIELD infrastructure historically is looks like this. You've got a R client that connects to Opal or similar software, and the R server and the database or something that is like a database. So the limitations of this infrastructure is that the data needs to be in tabular format only. Which can be a kind of problem because if you are dealing with different format, it does not fit in the database, and it's like pushing a circle into a square. So obviously you got problems. It requires the data to be managed by Opal, and some institution may be reluctant to do that because it requires effort to move data from their original repository to the new one. And so there's no support for large to big data sets because it does not fit in a SQL database, but it does not fit in a memory data frame as well. So it can be a problem. So the solution was to delegate the connection to the data management system to R. So Opal no more manage the data. Opal will know how to connect with the data, but will not establish the connection. It will be the R server that will do the hard work. So this enables to access to any data structures of any size. I mean, we are in a pure R world, so anything that R is capable of, the R server of DataSHIELD will be able to do the same. And it does not limit the concept to data. In fact, you can also access the new computation facilities. So I will give you some examples. So now with the resources, the DataSHIELD infrastructure looks like this. It does not replace the previous one. It's a complement. Now you can access the data through a table, but also as a resource. So what Opal has is this symbol is a link. So Opal knows how to connect to the database, to the data. And when you will perform the data assignment operation in DataSHIELD, it would tell our VR server how to perform the connection to the data, and it's the VR server that will make the connection. So it can be a database, can be a file repository of any format. It can be a big data analytics system, anything. So that unlocks the data universe that you can access. As examples, the base one supported, of course, CSV file, compressed or not, SQL database table, R object stored in R data file. But you can imagine different kind of resources format, and H875 dataset, OMOP database, J4J server, This one was used by the Juan González team. An HPC server accessible through SSH, Python script, a big data analytics system like Spark, an app in Docker images. Just name it. There's no limit. So how do we describe this this resource? We need three information. The first one is mandatory. It's the location of the resource, so where it is and how to access it. And this is a web standard. It's the URL that you use every day in your web browser. So it takes a protocol, HTTPS, for instance, the host and the path to the data. But URL is much broader than that. You can say, for instance, if I say MySQL, this IP number, it says that this is a database, MySQL database, and the database called SIM, and inside there is table SIM and SIM1. It can be a file on a local, it can be a file somewhere through SSH, it can be anything, and it's described by a URL, which is very strong web standard. Optionally, but in most cases you will have this, it's credentials. So how to access this resource is separate from the location. It's a username, token, secret key, anything. And you may need to have a, a format description, because if it's our object inside our data file, you need to know what is its class. It's a compressed file, you need to know which reader will take in charge the decompression and the reading of the data, etc. So to handle these resources in Opal, there's a web pages. So it's project based. So inside the project you have the tables, but you have also the resources, and it can be quite difficult to write the URL as the reader, the connector expect to have it. So there is a rich interface that is a form. So you just have fill in the different fields, and it will build the resource as expected. So it's very user friendly. And then you can set the permissions to access the resource, this resource or set of resource. There is also R API. So if you want to automate the creation of resources, it's possible to do it programmatically. The DataSHIELD permissions for the resources, it says like you can view the resource without accessing.
Hello. Oh, I think we've lost Yannick. We'll give him a minute to see whether he's able to reconnect. Yannick, can you hear me? We can't hear you, I'm afraid.
He's muted. There he is.
Yes,
Okay,
you're off mute.
Can you hear me?
Yes, I can hear you now. I'm afraid we've lost your slides though.
Yeah, where was it in that one?
It was showing the image of the importing data from GH4GA using dsOmics.
Okay, so that one.
Can't see it at the moment. It's still showing a black screen for me.
I need to share. Need to share again, I guess.
Yeah, yes, I think so. There's a warning message coming up for me saying that your bandwidth is low. So I don't know if you want to say turn off the webcam for yourself, and we can just have your voice on the screen.
Okay.
Thank you.
Okay. Can you see it?
It's for me. It's still showing that it's loading the screen share.
Okay.
I am wondering whether, Yannick, it's possible for you to maybe email, oh, we've gone. I was going to say email his presentation to someone
Yeah.
or someone, and then do it that way.
Are you there, Yannick? Would that be possible for you?
I think he's not there. Oh no, he's there.
Okay. I mean, should we move to Juan's presentation then, and we can come back to Yannick maybe afterwards. Oh. Hi, Yannick. We can see your presentation now. Can you hear me okay?
Yeah, I can hear you. I've switched to another network, so it should be better now.
Okay, fantastic. Thank you. Yeah, so I think, yes, this was the slide we were on. Yeah, perfect. Thank you.
Okay, so I was about to talk about the DataSHIELD permissions. So you can see the resource, but you do not have access to the credential. Just like when you connect to a web page, you have the URL, but you end up on the login screen, so you can go further. So that's basically the same idea. So what the resources on the DataSHIELD server side consist of using a resourcer R package that I've designed, and it contains a description class which is called resource, and the data resource connection and interpretation class, which is a resource client. So this class contains coercing functions. So if you want to transform your resource into a data frame, a table, or raw data, and also action functions for executing a command, submitting the request, etc. So it's extensible. So the most common resources are covered by the resourcer package. But if you want to extend to a new source of data, it's possible, and that's what the group of ISGlobal with Juan has done with the dsOmics data. And it's also DataSHIELD compatible in the sense that there are some assigned functions that I can show you. So on the client side, there are new function in the DSI package. So DSI stands for DataSHIELD interface. That's what we use on the client side. So it's possible to list the resources that are available on the connection. It's possible to assign a resource, but when you will assign a resource, you will create the object that will take care of establishing the connection and retrieving the data. And afterwards, you can do the coercing to a data frame with a function. That one is called as resource data frame. So it tells to a client object to establish a connection with the data and make it a data frame. So we're back in the standard DataSHIELD procedure on the server side. Yeah, so there have been some publications about the resource, and this one is very described extensively what is the resource and how it is used with omics data or geolocalized data. It was written with Tom Bishop and Juan González. And there's also supplementary material in the book down that comes with this article. And I do recommend to have a read of that. There are a lot of valuable information. The next topic is about the profiles. Apparently, there is a confusion with the profiles, the origin of the profiles. So the profiles are coming from the DataSHIELD interface. It has been implemented in Opal version 4.2, so 6 months ago. It's just new that it's available in Armadillo as well, but the origin of that is a work on the DataSHIELD infrastructure, generic work on the DataSHIELD infrastructure. So the rationale of having profiles is that you basically in the standard DataSHIELD have a robot or Armadillo that connects to our server, and all the sessions live in the same configuration and environment, and so it's pretty rigid. The problem is that it's difficult to upgrade the R base and packages, because when we represent our server, in fact, it's a multiple piece of software, so hundreds of packages and system libraries, and so it's difficult to upgrade this and maintain it. And in practice, people just leave the R server with old versions and deprecated packages, so it was a problem. It was not possible to restrict the access to some packages and to have different R options, so like the different privacy level for different groups of people. And it's as a consequence, it was difficult to reproduce an analysis environment. So the solution is to have the ability to connect to multiple R servers, and the ability to have a different DataSHIELD configuration per R server, and the ability to have permission to use the DataSHIELD configuration and not the other. So these are the DataSHIELD profiles. So in Opal, how it is implemented is that let's say you have R server A and R server B, so it defines two different profiles, profile A and profile B, because there are different packages that are installed in these different R servers. But you could also define a profile B prime, for instance, that is a derivative of the profile B with different R options, different access control, etc. And now, when you create a DataSHIELD session, you need to decide in what side it will go, either in the profile A or profile B or profile B prime. So it will affect where the DataSHIELD session will live, R server A or R server B. So in Opal, there is a graphical user interface for administration, where you can manage the profiles, and you can also see that you can enable or disable the profile. So when you are changing the setting, nobody can create a DataSHIELD station, so it's safer. So you can set the permission, and as before, you have the list of the functions that you want to expose or not. And there is also RPI, so if you want to automate the creation of the profile, it's possible. From the client side, it's very simple. When you declare the login data, you just have to specify what will be the profile you want to work with. And this information is not mandatory. So if you connect to a server that does not support the profile or has only one profile, so it's quite obvious, it will fall back to the default profile. So it's not necessary to have it, but if you can specify one, it will route your request to the right R server. And you can also list the profiles available in each of the DataSHIELD nodes with the function DataSHIELD.profiles. I would like to emphasize that when you define a profile, it's not just a matter of having different R servers. It's also having the client side that fit with the right R server, because in DataSHIELD, client side are bound together, so you expect that server-side profile will be mirrored by a client profile. And to do that, I've explored the possibility to do that with the R package. And you could have a look at this DS project template that can be useful for inspiration. And the idea is that, for instance, there is a new version of DS base that is coming. So let's say, for instance, that on the client side, you have your analysis that were built with the DS base 6.1, then you will have to, well, all the DataSHIELD infrastructure maintainer have prepared different profiles for dsBase 6.1 and dsBase 6.2 in each of the nodes. So from the client's point of view, it will have to, the user will have to specify, I want to work with the 6.1 or I want to work with 6.2. And you cannot mix the two together, because if you call from 6.1 dsBase 6.2, it will fail, and the other one will fail as well. So either you are all on the green path or on the red path. So it's clear for me that you need to have a client-side profile, and the Renv package is what I recommend to use. And you see on this in this graph as well that it's important to have our servers consistent between all the nodes. So that's the next topic, deployment. And with the deployment, there's a question of the scalability, which is the ability of a system to handle a growing amount of work. So you can scale up by adding more power, CPU, memory to a single computation node, but you can also add more computation nodes. It's like scaling out. And when does it happen? Say, for instance, when the analysis complexity grows, you need to scale up. You need to have more power for our servers, and that's the option of creating, for instance, the profile A. So you need the biggest R server. So you want to restrict the access to some of privileged users. So you can do it in Opal. You can specify this is the profile only for this people. If you have more users that who are doing a regular analysis, you can scale out. You can add similar R servers. So, and it will constitute, from the Opal point of view, a cluster of R servers, and to which the same profile will apply. And this way, Opal will decide to load the balance, to balance the load to each of the R servers. So in this infrastructure, it's very simple. There's no additional software required, like your load balancer. Opal takes care of the work, and you're good to go. So it's possible to scale up and scale out. So to ease the deployment of the R servers, we provide containers, Docker containers, to have isolated runtime environments, reproducible and shareable between the members of the DataSHIELD platform. And everything is discovered at runtime by Opal, so you do not need to restart Opal. You just start a new R server, it's discovered and ready to be used. So we provide some base Docker images, very extensive documentation to build your own profile and R server image. And we also provide support to create new resource packages and R server build. So what about the future? Given the feedback of the DataSHIELD community, I think that it's important to work on two topics, monitoring and auditing. Monitoring, because it's good to have a feedback of what is the R server activity to help with the scaling decisions. So right now, it's when the R server gets killed by the overload that people know that there is something wrong with the load. So it would be good to be more proactive on that regard. And given that, we can make a workload control, so to protect the R server to be overwhelmed. We could also have a user quota to protect the R server from abusive usage, like putting many DataSHIELD sessions, and to record the effective computation time. So in the end, it's not necessarily about monetizing the usage, but be aware of the scaling decisions that need to be taken. The auditing is an important topic for the trust. And currently the user activity is logged, but it's difficult to access. So maybe there's some room to improvement. And we could also have some pattern recognition to for instance, if someone is trying and fails repeatedly, maybe there is a kind of brute force attack or something like that. Okay, thank you for this, and thank you. You can connect for supporting this work, the DataSHIELD team, Master Research, who's contributing to OBIBA software, ISGlobal, and close relation with Juan González and my company. Thank you.
Thank you very much, Yannick, and thank you for overcoming the technical challenges. I don't know if you saw in the chat, but you were offered a place in Barcelona, I believe, if your internet connection was causing a huge problem. Does anyone have any questions for Yannick about the presentation? Please raise your hand. Oh, we have a hand up from Ollie. Are you? Yep.
Yeah, I'm unmuted. Hi, Yannick. Yeah, interesting work as ever. I always really enjoy your talks about what's coming up. For the DataSHIELD server profiles stuff, so I haven't looked at this at all yet, so I'm, you know, quite ignorant of it all. For all the disclosure control settings, you know, we've got those, whatever it is, 10 or so different disclosure settings that tend to be set at the sort of OPAL level, I guess. Is it currently possible to have those different in different profiles within OPAL, or is that sort of on the roadmap for the future?
No, it's available since OPAL 4.2, so it was released in July, so maybe it was below the radar. So yeah, it's available, and as you said, the R options, so all the disclosure settings, that's I put it part of the DataSHIELD configuration, and you can have several DataSHIELD configurations for a single R server. So it's you can really fine tune your settings.
Okay. Oh, brilliant. Yeah, no, I'll have to have a play around with that. Cheers.
Great. Was there any other questions from the audience for Yannick? I don't think there's any hands up. I guess, I mean, one question, and this probably speaks more to my ignorance of servers and everything than anything else, I wondered, was when you presented the diagram with the profile B having 2 servers with, 6 data sets and 3 in each. And then when you mentioned about the workload balancing, I wondered whether you could foresee a situation whereby actually you had versions of the data sets in each of the servers, and then essentially it was just workloaded so that, if you were doing a high intensity task, it might just go, okay, well, I've got spare capacity over here, I can utilize that server rather than return to the same one. So actually just duplicating the data across the servers, as it were.
Yeah, so in DataSHIELD, the sessions are stateful. We talk about stateless or stateful. Stateful is that when you create a session, it lives forever on a host. So you cannot balance each function call to this host or the other one. It's once you have created a session, it lives in that host, and that's it. So the balance of the work can happen at 2 levels. When you create the session, so you will decide, depending on the busyness of the server, to create it in that server or the other one. And it can happen also when you submit an operation, our operation. You can check that the server is busy, so I will delay or I will postpone the action and give some feedback to the user that you will have to wait, but the work is available, and then you make our work effective. Okay. And the other option to balance work is to use the resources, because with the resources you can delegate to another computation facilities. So let's say you have a HPC. So in that case, the R server will be just an entry point, but to submit a job on the HPC, and it would be the HPC that will do the artwork. So the load can be balanced that way also.
Great, thank you. Yeah, that's again clarified my lack of understanding there. Did anyone have any other questions? Ollie's got your hand up again, or is it still the same hand?
No, me again. Another question.
Okay.
Yeah, no, I've just looked up your config file there, your example, Yannick. That's really useful. So my next question is around having different functions available to different people in different profiles. Is that on the roadmap for sometime soon?
It's already available. I mean, it's a part of the it's part of the DataSHIELD configuration. In the DataSHIELD configuration, if you remember, you can list which functions can be used, and it's discovered from the DataSHIELD packages that are installed on your server. So, for instance, dsBase declares a list of functions. But in the configuration, you can remove some function that you don't want to make available. So you can very fine-tune your configuration.
So if that's done at the profile level, then I think I've perhaps misunderstood Stuart and Alex's talk a little bit earlier, where there was the sort of the permissive mode. Was that an example of a profile, or was that separate?
No,
that
it's
was more a
separate.
wrapping up of the DS space, so you could have it in one profile be configured to be permissive and another profile be not permissive. And that would be just by changing the options in the deployment.
So why? So I'm not sure I understand the need for what you've done, Stuart. If you can just,
I think it's a shortcut. It's
right.
like you just have to turn on a switch and you get all the functions available or not.
Yeah.
Otherwise, each administrator will have to select. Oh, I don't want this one, etc. So with what Stuart has, it's just turn on or off.
Yeah. So right. you don't have. There's no kind of avoids of the potential for administrator error.
Mm-hmm.
So it guarantees that if it's in permissive mode, it's in permissive. It's not, it's not. You don't get, yeah.
All right. Yeah, I think I understand that now. Thanks.
Great. Well, thank you, Yannick, for your presentation and answering the questions. Move on to our next presentation and the last one of this session. And this is going to be presented by Professor Juan Ramón González from ISGlobal, which is the Barcelona Institute for Global Health. And the presentation is Orchestrating Genome-Wide Association Studies Meta-Analysis in Multi-Cohort Studies through dsOmics, the DataSHIELD package. And I think I've got GWAS right there. So over to you, please, Juan.
Okay, thank you. Let's see. Okay. Can you see my screen, the full one?
We can see the presenter view at the moment, so we have the slides quite small, and
yes,
then the next slide.
Just a second, please.
No problems.
Now better?
Yes, perfect. Thank you.
You're welcome. So, as you mentioned, I'm going to present how to perform GWAS meta-analysis using dsOmics. Just to let you know that dsOmics is not only designed for performing GWAS studies, but also for other type of omic data analysis, such as transcriptomic data analysis, epigenomic data analysis, and so on. But for the sake of the timing, I'm just focusing on this problem. So just, I suppose that you are familiar with what GWAS is, but just in case if any one of you have not seen any of this type of analysis. So the idea is that we sequence the whole genome, and here, for example, we have a, which is called a SNP, a single nucleotide polymorphism, which is a change in a single position of the genome. And what you are doing is you have cases that has been diagnosed with any disease and controls, and you have here some individuals with this mutation, and here other individuals with this mutation, and the idea is to compare the frequency of this mutation between cases and controls. At the end of the day, we obtain this Manhattan plot that stands for the p-value obtained for each of these SNP across the genome. And in that case, for example, this dot corresponds to this comparison. And here we could see that this SNP is highly associated with the disease. So the problem is that in the GWAS studies, the effect sizes are moderate to small in magnitude. And that's why most of the existing GWASs are not well powered. And what people are doing so far is just to combine GWAS data from different cohorts or studies. And this is what is called meta-GWAS. Of course, pool analysis can also be performed in order to increase power, but the problem here is that you normally don't share the raw individual data among cohorts. So this is the difference between meta-analysis and pool analysis. As I mentioned, the meta-analysis is the approach that many consortia are adopting. You have different studies in different cohorts, and you prepare a script having the quality control, the GWAS, and the output. You send the script to the cohorts, and the cohorts send back a report having the sample size, the beta values, standard error, and p-values, and then the results are meta-analyzed, and we can have some results like this. On the other hand, you can perform what is called pool analysis in our, let's say, language, but in GWAS, it is called as mega-analysis. The idea is to have individual data or individual level data, put everything together in a single database, and then run the analysis and obtain the pool effect, which is pretty much similar to the one we obtain with meta-analysis. So the problem of running this analysis is that the data are among different institutions, and normally what it's doing is to centralize the analysis in a single center, and then the data has been obtained from different single analyses that it can have problems because, for example, the reproducibility cannot be assured because any single data analyst is performing analysis in their own hospital or cohort. So the challenges actually are not technical ones. So the problems are the ones obtained from legal or regulatory barriers that can difficult the transfer to patient level among cohorts. Of course, the stringent data protection and GDPR are another issue that not allowed to transfer data, including the case of having pseudonymized data across countries, and that's why people are adopting this meta-analysis approach. So, as you know, DataSHIELD can be adopted to solve these issues, and we can run the analysis in the Opal servers and then meta-analyze the data in our client side. The problem is that there are two limitations. The first one is dealing with big data that has been addressed by using the resources, as Yannick has mentioned. And the second one is to implement scalable methods for both meta-analysis and pool analysis. We're going to see in a minute why this is a problem within DataSHIELD. So the resources, I'm not going to talk too much about that because Yannick made a really nice presentation of the resources. But just to let you know that thanks to the resources, we are able to use other programs that are specifically designed to perform GWAS data analysis, such as Blink or Impute for imputing SNP data, or SNP Test, which is a really fast program to run GWAS analysis in imputed data that normally is an analysis performing 40 million of tests in a row. So this is a good program. So we developed some resources to have these computational resources available through Opal. Okay, so this is something we can run, and if a cohort is having imputed data, you can run this SNP test and get the p-values very, very fast. Another advantage of the resources is that you can use other type of data, such as expression set or randomized experiments that are available through Bioconductor, and that's why we can run, for example, transcriptomic or methylation data analysis. This is what Yannick described, and this is how DataSHIELD is, the dsOmics is organized. We have, of course, a dsOmics client package that is able to run the analysis, having, for example, here 2 different cohorts. We have a table with the SNPs in rows and the individuals in columns, and another table which is having the phenotypes. So this is normally stored in Blink data format or BCF files, and here in another table that can be a table or data frame, we have the cohort, the covariates and phenotypes and so on. The idea is that this row here matches with this group here, with this column here. And in dsOmics, we can run 2 different data analysis. Just forget this part, which is for expression and transcriptomic data analysis. Let's focus on this part here. There is a function that is called dsGWAS that is performing the meta-analysis as if you are involved in a consortia. I mean, dsGWAS run GWAS data analysis at each study level, okay? And then this summarized data, which is correspond to the beta value, standard errors, confidence intervals, p-values, are sent back to the client side, and then we can meta-analyze the data using our function called meta p-values, or another function that is meta beta values. Okay, we run this. We created this meta p-value function because in transcriptomic, people are meta-analyzing the p-values, not the beta values as in the GWAS. But of course, we also created a function called meta p-values that is implementing fixed and random effect models. And we can also run pool analysis using this dsGLM SNP. So the idea is that you have this function that is putting all the data in a single table, but you know how DataSHIELD is working. It is not doing that, but it is performing non-disclosive analysis as you have the data in a single table, and then you obtain the virtually pool results that corresponds to the pool data analysis. So if you want to run the GWAS data analysis using the pool data, what you are doing is calling dsGLM 1 million times. So this is not a good idea. This is not scalable with this problem. So we need to run thousands of millions calls to dsGLM. This is not a good solution, even in the case we are using, for example, multiple cores. So this is not a good idea. In my last You Can Connect meeting, I had this slide. I promised in the next release of the dsOmics have an approach that is reducing this time, the computing speed. And this is what we obtained. So we have performed a benchmark analysis using our new function that is called dsFastGWAS, which is performing a virtual pool analysis of all the Opal servers. And as you can see here, we can run this analysis in almost 1 million SNPs in less than 40 seconds. So it's really, really fast, okay? And of course, the result we obtain using this approach is the same as if you pull the data in a single server. So just to illustrate how to do this with DataSHIELD, I'm going to use a public data, which is available through European Genome Archive, EGA. So this data has been generated by Seneca project, which is having this number of samples and this number of SNPs. I must say that there are 4 million of SNPs, but we subset these samples just to speed up the process, but because we decided this before creating fast GWAS. So now I guess we are going to change the example having the 4 million individuals. What we did was to split the data in 3 different cohorts. So these are the sample size. And then to set up this DataSHIELD infrastructure, we have 3 different Opal servers, having the Seneca 1, Seneca 2, Seneca 3. And as dsOmics is organized as following, you have the BCF files for each chromosome as a single resource. And the phenotypes is another table, is a data frame or table. So we also implemented other stuff following Mariona's, let's say, recommendation or ideas, because she always wants to have everything as simple as possible. So we also implemented methods to perform quality control in meta GWAS analysis. So the idea is that you have the 3 different cohorts. You have the BCF files as resources. We run independent GWAS analysis and we perform what is called meta-level quality control before performing the meta-analysis. So by performing this meta-level quality control, we can see whether or not there are any issues among the cohorts. And then if there are, we can run a new function to can fix these problems and rerun all the analysis. So we implemented different type of plots for assessing the quality control of our GWAS data. One is called EIF plot. The idea is to see whether or not the allele frequencies among cohorts are similar. So this is useful to detect something related to population stratification. We also create the PZ plot that is able to capture any problem with the beta estimate, the standard error of the p-values, okay? And also we have another plot that is related to the phenotype, just to see whether or not the different GWAS are having different, they are having heterogeneity in the phenotype, because if there is, maybe the pool analysis is not a proper approach, and maybe we need to do, for example, meta-analysis using random effect models. So these are the plots we obtain. Of course, in our case, in the Seneca project, we are not having problems because everything is in the diagonal, as we expect. Because what we did was to split the Seneca in 3 subsets, and of course, they are belonging to the same population, and that's why we are not having problems. But for example, if you have a problem with one cohort, maybe this plot is not like this, is having another oddity, having an increase of the allele frequencies close to 1 or close to 0.5 and so on. But in principle, this is what we expect when you have a meta GWAS study having comparative cohorts or GWASs. Then once we are able to perform the analysis because everything is okay, we simply run the analysis using dsGWAS. And you can put here your genotype object. You see a resource that is obtained from the Opal servers. And this is performing the meta-analysis, the GWAS cohort by cohort. So here you have the resource for cohort 1, cohort 2, cohort 3. And then you can also obtain the Manhattan plot very easily. And then you meta-analyze the results using either meta p-values or meta beta p-values. So this is already implemented. We also implemented something that is useful for people who are doing GWASs, a locus thumb plot. So let's imagine that you are interested in having a look at this specific SNP, which is almost significant. So we can locus thumb this region here, having the SNP here and the genes that are close to that SNP, just for interpreting purposes. Of course, we can run principal component analysis just to see whether or not there are any issues with population stratification. We can obtain the allele frequency in the pool as a pool analysis. And we can run, for example, using dsGLM, a single estimate for a given SNP For example, the one that is passing the multiple comparisons of Bonferroni correction. And we can have here the p-value, the standard error, the estimate, the effect. And also we can add some SNPs that are, for example, in a region or gene or somewhere. So this slide is just to let you know that original, pool, and meta-analysis are providing the same results, okay? The same standard error and the same p-values. So this is just to illustrate that if we run the analysis having the original Seneca data, having the 3 cohorts together, are performing the same results and the pool analysis implemented in DataSHIELD or the meta-analysis implemented in DataSHIELD. So now we have also implemented functions to compute the polygenic risk score and run analysis. I also think that you are already familiar with polygenic risk score, but just in case, polygenic risk score is a method to combine different SNP effects. For example, let's imagine that you have 10 SNPs that are important for your disease. What you are doing is to combine the effect of each single SNP in this polygenic risk score, just multiplying the effect by the dosage. The dosage is 0, 1, 2, depending on the number of the rare or risk alleles. And the idea is that if you run this analysis, you are able to distinguish controls versus cases population, and these polygenic scores are good markers to stratify individuals depending on different risks. So we implemented 3 different methods. The first one is you can put a table having the SNP where it is located in chromosome position, which are the effect allele, the reference allele, and the weight. This weight is this beta here. And also you can have the same information, but if you don't know the chromosome and the position, you can put simply the array's name, okay? And the third option is that you can use the polygenic risk score catalog. Here you have a catalog having this number of polygenic risk score that has been obtained from literature. So here you have the number of polygenic risk score. For example, this one is related to breast cancer. So you don't need to provide this information, because from this catalog, you can obtain the beta values and the effect and the effect alleles and so on. And this is performed very simply in DataSHIELD. You use dsPRS to create this new variable, to create this new variable. For example, you add to your resources the polygenic risk score corresponding to this PRS. You add this information to the table that is called phenotypes. So you will have a new column. So then when you run dsGLM to your phenotype, your covariate, and so on, it will be a new variable, which is called PRS. And we add here the name of the polygenic risk score you are interested in. And then you can run a simple GLM, because this variable will be available thanks to this new function. And then, for example, here you can see whether or not this polygenic risk score, which is here, is associated to cholesterol level. And here you can see as the p-value is not significant, but okay, this is how you can run. So there are 2 steps. The first one, you create a new variable in the results having the polygenic risk score, which is a variable is a new covariate, and then you can run the analysis you are interested in. So there is a vignette which is available here. You have the link in the chat, explaining all this stuff. I also like to thank Xavier Escrivá, because it's a joint work with him. He has implemented most of the new functions. I started some months ago, and if you have any question or comment, you can send me an email as always. So thank you.
Thank you very much, Juan, and very interesting. I'm delighted as well you're able to join us from the surface of the moon today. Very good connection. Does anyone have any questions for Juan? I mean, not really a question, but I guess, as you know, with the EGA moving to a federated model, this certainly could have really usefulness in that you're going to be having data set now distributed across Europe, and the ability to bring it together more easily. It seems like this is a really timely package.
Yes, I thought so. It is timely, but we must say that there is a publication in Nature Communication of another approach using other different techniques that actually they are mentioning that DataSHIELD is not a good solution for that. And we are thinking of writing a letter to them because this is not a good thing to have this bad, let's say, publicity. But you are right. We are just running up to finish the functions and setting up the examples because we want to publish this as soon as possible because it's a very timely opportunity. Okay.
Absolutely. Thank you. We have a hand up from Doa, is it? If you're able to unmute yourself.
Yes, hi, I'm Doa. Sorry, I am an editor in Nature Communications. And this is very timely, like you said, and I'm very interested personally in growing this area at the journal, and which is why I'm actually here. And I'm not very familiar with the amount of like engineering that goes into some of these efforts, and that's just my ignorance. So, which is why I really am curious to hear, like, why is it so difficult to get a function to accelerate so fast? Is that like you said, you have like a 300 times gain in speed now. So what extent of engineering goes into that? Is that just making the functions flow a bit better? Is that really like some sort of like change in the infrastructure? It doesn't sound like that, right? So
No.
I'd like to learn a little bit about that so I can appreciate.
No, not at all. It's not related to engineering or IT ideas. It's more related to statistical maths. As you know, so if you run a GWAS data analysis, you are doing the same GLM every time. Every time. This is the same model, just changing one covariate, SNP1, SNP2, and SNP3. So if you want to estimate this parameter, always you need to compute, for example, the mean of the outcome. Okay. So if you compute only once the mean of the outcome, you don't need to rerun the mean of the outcome 1 million times. So by using this idea, you can split the results or do the analysis in a clever way that avoid you to run the same method or the same let's say computation. For example, you don't need to invert the matrix every time. Once it is inverted once, there is a clever way to incorporate the information of a new covariate, and this is what we implemented. I can send you a paper describing that ideas because they are really clever.
Yeah, thank you. Appreciate it.
You're welcome.
Thank you. Did anyone else have any questions for Juan about the work that they've done? Don't think we have any hands up. Ah, no, we had some applause for you. Okay. Well, I'd like to thank all the presenters in this session for your efforts, and I'm sure we'd all join in a round of applause for everyone and say well done for the work that you've put in and the developments that you've made. We'll be breaking now for until 3:30 UK time, GMT, so 4:30 if you're in European time, such as myself. So please go and enjoy some coffee and a comfort break, and the breakout rooms will be open as well if you want to go and have a chat with people about some of the talks that we've seen. And we look forward to seeing you all back in half an hour's time. So thanks again to the presenters, and enjoy your break.
I'm just going to chip in to say there's a third and final survey just going up about what you'd like to see next year.
Okay. Yep. Thank you, Alex. Hopefully people haven't run away super quickly.
We'll catch them at the end.
Yeah. Yeah, I didn't know that was coming. So.
Sorry, I accidentally opened the breakout.
Did you mean to open the breakout then, or not?
I've opened the room, so yeah.
Oh, okay. I saw it pop up and assumed that that was meant to be open. So apologies if not. If I shouldn't have announced it.